Okay, so don't feel weird just because it's recording. It's just like class, okay? In fact, in a couple minutes, you'll probably forget. So, this is Standard 8. Students, now remember, there's like two parts to Standard 8, solving and graphing, right? But basically, it's quadratic equations. So, if you can solve quadratic equations and you can graph quadratic equations, then you can do this standard, and that's what we'll go through. Now, just a quick review here. The solving part. If you're going to solve a quadratic equation, there's basically these three methods you'll use. You won't use all three of them. You just choose the most appropriate one for the question. Factoring is the first one. Complete the square, or using the. Anybody? Good. Okay. So these all basically, I mean, you use those techniques when you graph, but those are basically solving techniques. So if you're going to solve a quadratic equation, you're trying to figure out what does x equal. There's usually two answers, and you use one of those methods. The other part of the standard is that you have to be able to graph these. So here we go. Question 1 says y equals x squared plus 3. And you have to graph this. Okay, so first of all, is this a quadratic equation? Yes. We know it's a quadratic equation because the x is squared. Okay. Good. Which means it's a quadratic equation. When I graph it, it's going to look like a parabola. Okay. Now, we're not going to go as in depth with every question, but this first one, let's just to get off to a good start. What you should probably do is try to imagine what this graph looks like. Right? That graph looks like this. The vertex is at 0 and 0. And it has this shape. And remember, you go over 1, up 1, and you get to a spot there. This graph here is written in standard form. A is 1, B is 0, C is 0, right? So if you know this, then you look at your equation, you say, all right, this is also in standard form. A is 1, B is 0, C is 3. So if you compare these, the A stayed the same, right? 1 and 1. The B stayed the same. The only thing that changed here is the C. So hopefully, you know what these three letters do. The A changes the shape of it. So if the A is 1, that means this over 1, up 1 is still going to work. The C shifts the parabola up and down, and the B shifts it right and left. So we know if B didn't change, so it didn't move left and right, so the axis of symmetry is still right there in the middle on the y-axis, but what happened is the C went from 0 to 3. So this parabola just moved up 3. Right there. Right? Over 1, up 1 is the shape. Okay? So if you knew that much, then you answer this question right, and you select choice A. All right? Any questions about that? Okay. So question 2 says y equals negative x squared minus 2. Okay. Again, that's written in standard form, just like this. Okay? So, I don't think you necessarily have to write down A, B, and C on the side like that, like I did, but it's pretty helpful. Okay, Tony, what's A? A is -1. Charlene, what's B? Oh, Charlene. Good. Rebecca, C, -2. Okay. See, B is 0. This basically says this. Okay. All right, so here we go. Remember the old one was not 0. 1, 0, and 0, right? So it looks like 2 letters changed, right, Amanda? Which 2 letters changed? C did and A did, right? So, Ella, if A and C changed, then that means B stayed the same. Okay. Now, what does B do to the graph? Huh? Okay, it changes the direction. Like, does it move it diagonally, or what does it do? What direction? Side to side, okay. So, it didn't move side to side, right? Which means the axis of symmetry is still right here. Can you see that? The C moved down 2 from 0 to 2, which means the vertex must be down 2. There's the vertex. Now, the A is -1. It used to be 1. When it's 1, that means over 1, up 1. We have -1 here, which means over 1, down 1. And if you can do that much, I mean, obviously it's not the neatest graph you've ever seen, but you can obviously tell that this is choice letter. Yeah, okay. Any questions? Anybody get those 2 right, A and C? Wow, the whole class, the entire class. Wow. Oh, Nick, you missed it? Oh, okay. All right, number 3. Here's another graph question. Tina, would you say that's a quadratic equation? Yes? Why? Good, because the x is squared. Okay, so it's a quadratic equation. It's in standard form. Okay, Alexis, what's A, B, and C? A is -3. Oh, B is 1. Good. And C is 1. Okay, good. Right? Okay, so the original is 1, 0, 0. Okay, it looks to me like all 3 letters changed here. Does that seem true to you guys? Okay. All right, so it moved to the side, it moved up and down, and the shape of it changed too, right? All right. So if you have this shift with the B, then what you have to find here first is, where's the vertex? Right? And the starting point is, if it's in standard form, you could use this formula. It's very important. And it tells you where the axis of symmetry is. Okay? So when you're graphing these quadratic equations, the vertex is the most important part. You really need to figure that out first. Where is that? And on a question like this, you can use this formula to help you find the axis of symmetry, which will tell you the x value of the vertex. It will tell you how far left and right the vertex is. So we're just going to use these ABC here into this. -1 over 2 times -3 is -1 over -6. 1/6 Can I erase this? Okay, that is where the axis of symmetry is. I guess we'll put it right here. This is at 1/6. Or, I don't know, if you want to think of it as a decimal, sometimes that helps. Does anybody know what that is? 1 divided by 6. Anybody have a calculator? 0.16. What is it? 1.16? Okay. Okay. So 0.16, like less than a quarter. Pretty small. So the vertex is over here at 0.16. Now look at the choices. Do you think there's any choices that you could eliminate right now? Yeah, A is out. Choice A is out because on A the vertex looks like it's over here, doesn't it? Any other choices? D, good. D also looks like it's got this vertex over here on the left, so D is out. Okay. So it looks like it's between B and C. And we're going to have to figure out what this y value is, see how high the vertex is. And then once we know that, we could choose the correct one between B and C. So then the big question is, how do we figure this out? If x is 1/6, what's y? Yeah, plug in the 1/6 into here, right? Good job, Tony. So you get y equals -3 times 1/6 squared, right? Plus 1 times 1/6, I'm just going to write 1/6 plus 1. Okay. We got to do this. What's 1/6 times 1/6? Good, 1 over 36. Looks like this, right? Okay, plus 1/6 plus 1. -3 times 1 over 36 would look like this. That's this part. Right? And you could reduce that to -1 over 12. Okay, so this yellow part's -1/12. Right? Any questions? Just do multiplying fractions here. Okay, so we got we got to add 3 fractions together. I could tell by the looks on your faces how excited you are about this.
Yeah.
How do we add those fractions together? We find a common denominator. Does anybody have an idea of what we can make the common denominator? Jose, looks like you have a plan here. What's the common denominator?
Make them all 12.
Make them all 12, okay. -1/12 plus 2/12 plus 12/12 means y equals how many 12ths? 13 12ths. Right? Or a positive 1 and 1/12. What is that we just figured out? The y value of the vertex. Good. So that, is what's up here. Okay? Which means, oh my. You did that on purpose. So the vertex is up here at positive 1 and 1/12, right there. Yeah, you don't even have to graph the rest of it to pick the right answer here, right? It's between B and C. Which one is it? C, good, because B the vertex is down here. So the answer to this is C, which is number 3. If you were going to graph it, though, once you know the vertex, then you look at the A, it's -3, so go right 1, down 3, wherever that puts you. All right, any questions? Number 3. Okay, number 4. Okay, it says, what is the effect on this graph when it is changed to this graph? How does that basically change the way the parabola looks when you graph it? Is it going to change from opening up to down? Is it going to just translate up? I mean shift up? Is it going to translate down or shift down? Or is it going to narrow? Narrow means it goes like from this to this. Which one? Yeah, C. It's going to translate
C, Delvin.
or shift. Oh, you guys were working together and you said C?
Yeah.
What did he say?
He said A.
He said opens up from up to, he said it does this into this. What would I have to do to make it go from here to there? What would I have to do to this red equation? Yeah, negative x squared. Okay. Number 5, y equals negative x minus 3 squared minus 1. You have to graph this. This should go fast. This should go fast because it's in vertex form, not standard form, right? Okay, what's the vertex, Nick? Yes. It's the opposite of this, and it's the same as this, right? Alright, so all I got to do is graph this. 3, negative 1. That's there. It's either B or D, right? B opens down and D opens up. This one opens down because it's negative. A is negative. So this is like negative 1, which would mean over 1, down 1. And you get these points. B. Okay, anybody have 100% so far? Wow, everybody. All right. Okay, more graphing. Is this a quadratic equation even? I don't even see x squared. I don't even think this is quadratic. Oh, it doesn't say graph. It just says write it in standard form. Okay. Make it look like that. Okay, Denny, how do we do this? You multiply everything. All right. Let's multiply these first. What is that going to make? Good. That's C. Right? Any questions? What?
B.
Oh. Any questions about this? This multiplying part here, you could use FOIL or you could use the generic rectangle, and you'll get this. Okay, number 7. Graph. What form is this one in here, Brandon? What form is it in? It's in vertex form. Marcelo, are you happy that it's in vertex form, or would you prefer it were in standard form? You prefer standard? Oh. Okay. Marcelo prefers standard form to vertex form. Ian, what do you think about that? Do you prefer standard form or vertex form?
Vertex.
Why?
The vertex is shown right.
Oh, good, because the vertex is showing. Good. Okay, Alexis, what is the vertex? Alexi, what is the vertex?
It's -4.
Good. The opposite of this one and the same as that one. Right there. Okay, once you know the vertex, then look at the A, in this case 1, positive 1. I mean, that's not exactly what the graph would look like, but if you know that much, you could definitely answer this question right and put A. Good job.
I got it right.
Okay, anybody have 7 out of 7?
I originally had 7 out of 7 to the day.
Doesn't class seem like just slightly more exciting with this microphone on?
You seem excited about it.
It's like we're on TV right now.
I like it.
Okay, so this one, this is not a graphing question. It just says, what are the solutions, which is another way to say, solve this. You can usually tell it's not a graph because there's only x's. There's no y or there's no f of x. So, since this is really the first one we solve, let's kind of go through this a little bit in more detail. This is a quadratic equation. If you're going to solve it, you have these 3 choices. You can do it by factoring. You can do it by completing the square. Or you can do it by the quadratic formula. This factoring is by far the fastest and easiest, in my opinion. It doesn't work on all of them, but I think it'll work on this. If we're going to do it by factoring, we need to make it equal 0. So, right? Subtract these over here.
Or you could subtract the x.
Okay, oh, Alexi, I'm so glad you said that. So she just says, why don't I just subtract the x squared and write it like this, right? You could do that. The problem is you're going to have to factor out this negative if you want to factor it. So I guess the point is you always want to try to keep the a positive if possible. So I like positive 1 better. Now I'm going to factor it with the diamond problem. What multiplies to make -54 and adds up to -3?
6 and 9.
Okay. Now the zero product property comes in. That is, which one? D. B? No. D. All right. Any questions about 8? Okay. Okay, this already equals 0, so I'm going to try to factor it, and if it factors, then pretty happy. All right, Khalid, what do you think? Can we factor this? Yeah, what are the numbers? -6 and 4, that's right. Right? So the zero product property comes in, looks like that. So x equals 6 and negative 4, right? Okay. That is, which one? Now look, let me just point something out. If you get a quadratic equation like this and you have to solve it, and let's just say in 6 months or something you have to take a test like this, and you can't remember how to factor, what you can do is you just take the answers and you plug them in, and they have to make the equation true. So try a 6 in there, and that has to work. And then try it again with the negative 4. Put that in there. And that has to work. And if they both make the equation true, then that's the right answer. So if it's a multiple choice test, you can just do that with all the answers until you find the right one. Or if you actually know how to do it by factoring, then you do that to check. Okay. Any questions? All right, number 10. It says find the x-intercepts. To find the x-intercepts, it's sort of like, you think of it as 2 steps. Step 1, make the y equal 0. Step 2, solve for x. Okay? The x-intercepts, what you're trying to figure out is 0, not 0, something comma 0. Where are they on the x-axis? Where is the parabola across the x-axis? So, step 1, step 2. That's step 1. Step 2 is solve for x. So now this becomes a question just like the last ones, 9 and 8. If I can factor this, I'll solve it that way. Can you factor this? Delvin, what do you think?
9, negative 9.
Good job. You should go back and watch this video tonight, Delvin, because when you were in the bathroom, people were saying things about you.
Wow. Yeah, like you made me get a problem on that.
Okay, so you solve this, you get 9 and 2, which means the x-intercepts are 9, 0, and 2, 0. Like that. That is B. Okay? Any questions?
It was supposed to be C, like I said.
All right, solve this.
I was just finding out with C. You lying, you had A.
Yeah. All right, we have to solve this. Let's try doing it by factoring. Can you factor this? Yeah. Greatest common factor. Right? Like that. Factor out the x, then do the zero product property. If that equals 0, this will work. Or if that equals 0, this will work. And again, just take these, put 0 there and there. Is this true? Yeah. Put negative 2 there and there. Is that true? Yes. Okay, number 12.
What was the answer?
Oh, what is that?
A.
A? No. D. Okay, let's try to factor this. What's 42 times negative 30? 1,760?
50, 40.
Like that? Okay, what multiplies to make negative 1,260 and the same two numbers add up to negative 1? Chris, don't just shout out the answer. Oh, this is a perfect opportunity for us to practice doing that doubling, halving trick.
Yeah, let's do that.
Let's do that. All right. So what you do is you just think of anything that'll multiply to make 1260. Like how about 126 and 10?
Yeah.
Now if I subtract those, I'm not going to get negative 1. So those not the answer. But let's say I take half of this one, 63 and double that one. So half and double. That makes negative 1260 still. That's not it. Any ideas? Let's divide the 63 by 7. Be 9 and 140. That's no good. How about we divide this by 2, 18 and 70. That's no good. Any ideas?
35 multiplied by 2.
Oh, to multiply by 2, okay. 36 and 35. And if I subtract those, I get negative 1. Okay. It's not hard work. Oh, you did the quadratic formula. That might be some work. But good. I'm glad you did that because you can definitely do that. All right. So we're gonna have to make this box here. I think. So those go there. Okay, what am I gonna have to use for the sides here? 6 and 7. Right? So I get 7x minus 6 times 6x plus 5 equals 0. That's me factoring. Now I can use this method to find the two answers. What is that one?
C.
C. Okay, now honestly, who got that one right? Be honest.
How do you do it?
Okay, let me ask that again. Now, honestly, who got that right and didn't just guess? Wow. Everybody except you, Chris. Just kidding. All right. 13. I'm going to solve this by factoring. Right? That's factored. That's D. All right. Any questions about 13? Nobody? Huh? All right.
What did you get for? 13?
Okay. So this question says find the zeros. That's another way of basically just the same thing as finding the x-intercepts. So make the y equal 0. Solve it for x, right? Ian, why didn't I write plus y? Because the first step is to y equals 0. Okay. So this is like plus 0 right now. D. Now I have to solve this. So I'm going to make this equal 0 by subtracting 5 over here. And then I'm going to solve this. And if I could factor it, that will be the fastest. Okay. Okay, kind of took some shortcuts there at the end, but the steps are exactly the same as the last question after you factor it. That is B. Okay, now we're on 15. You have to solve this. You could subtract 12 and factor it and do it that way. Or you can just, if you can get this part here, the squared part by itself, then you could just square root the two sides. So the first step is just divide this by 3. That. Then square root both sides, and you get x equals plus or minus the square root of 4, which is plus or minus 2. B. (16). You could do the same method on this one. So basically, if you have to solve an equation and the b equals 0, there's no b, there's no term with x to the first, then you could do this method. You just get the x squared by itself and square root both sides. So, get this by itself. I need to add 39. Yeah, Ruben. What? No, I can't do that right now. I'm sorry. You can come in right at the end of class. I'll do it. Okay. Let's see, right? Okay, who has 100% still? Okay. The whole class. Okay, basically the same as 17, just try to get this part by itself, right? Some of you guys would try to multiply that binomial x plus 7 times x plus 7 and write it out like in standard form, but you could do that. It's definitely not the fastest way, though. Ian, what's 42 divided by 3? Okay, Rebecca, what do I do now? What should I do now? Right? Subtract 7. And that is D. Who got that one right? You guys always have a hard time with these. You did? No, you didn't.
I got C. I don't know how I got C.
Oh, we're almost done. All right. I think we'll make it.
So wait, for 17, you just find both sides.
Okay, same thing on this one, same as the last one, just square root both sides. You get this. Right? Subtract 9, and you get this. Divide by 11, and you get this. That is C. You should maybe try to, look for the doubles. Factor this if possible. 5 times 22. That's 2 and 11. There's no prime doubles here, so okay. What letter is this one?
C.
C. $19. Oh, write the equation in vertex form. Oh, so you got to do complete the square, all right? So you say, all right, I want just to say y equals x squared minus 4x plus what? 4. All right. You do half of this squared is 4, right? So how do I get from negative 3 to 4? How much do I have to add? To add 7. So I'm going to write plus 7 minus 7. These make this. Factor that like this, and then the minus 7 is out there. That is C. So we're going so fast here. We only have 2 minutes left. Okay, this one says, what's the maximum, right? Maximum means this is an upside down parabola. It points down like this. The maximum is the highest point. It's this. It's the y value of the vertex, right? What's the highest? That's the highest y value there is. So you got to find the vertex and then get this. Get the y value of the vertex. Right? Negative b over 2a. Right? Is that the maximum? No, that's the x value, right? Plug that in here. And you get 1 squared minus 2 times negative 2. So the maximum is 10. Okay, I think we can make it. 21. Solve this using the quadratic formula. Negative b would be 3, plus or minus the square root of negative 3 squared minus 4ac over 2a. That's, which one? C? Last one. Man, this is getting so crazy. In such a hurry, I can't even write it straight. Okay, solve this. I don't even know if that says solve. Yeah, you want to try to factor it? Okay. B. Yes. Okay. See you later.